All right, so here we go, 4.1. So in this, really what's happening in 4.1 is we're really just leading into the idea of graph theory by looking at specifics inside of it in more of a modeled situation. So if you want to start off in section 4.1 and just read, you've got the highway inspector and the traveling salesman, and just kind of read the little story there. So I'm just going to kind of jump into that. But basically in this section, we're going to look at the degree of a graph and then this idea of graph theory, which is what I was talking about. Is like we're establishing like the theorems that we can use to establish graph theory ideas. All right. So the main thing we want to think about here is that I'm going to kind of jump in just looking at all of these theorems. It comes down to this bottom line. We're talking to other. This is, like I said, it's a discovery section, but in like section 2 and section 3, we actually look at like what a degree is and so forth, and what a path is and such. But you might want to consider printing this page out or writing them down, because what this is going to help us be able to identify whether or not these types of routes are possible. And we don't have to prove these; we just have to apply them to determine. And so these will help us understand whether or not we can find an economical route or the route that meets the needs of the salesman. All right, so what we have here is that we have this highway inspector, and the deal with the highway inspector is that she wants to travel on every section of road, and in an interest of economy, she only wants to travel on each section one time. So has to hit all of them, but only one time. Whereas the salesman doesn't care, just wants to make it around the route, but doesn't have to drive on each street, just wants to be able to go to every town. So the question is can we identify these paths? So let's do on this side, sorry about that. Grab that, go back, open that up. Let's move this up here. There we go. Sorry about that. Let me get this moved where won't be in my way. There we go. Oh my God. Okay. So on this side over here, let's do the salesman. So this one will be the salesman. And on this side will be the inspector. And once you hit pause for a second and just kind of make sure. So remember that the inspector wants to go on every section of road, and the highway or the traveling salesman wants to just go to every town. So why don't you go ahead and draw quickly what you think. So hit pause and draw what you think would be meet those requirements. All right, welcome back. So you've hopefully gone through and taken a look at this. So the salesman, let's say that they started right here, and they want to go to every town. And they don't care if they travel on every road. So we got 1, 2, 3, 4, 5. And now at that point, they've hit all 5 towns. It didn't talk about having to go back where they started. That was just the idea. All right. On the traveling salesman, so on this side, on the other side, the highway inspector, let's take a look at what we need to do there. So let's say we started right here again. So that means we could go here and then, let me go back on that. All right, so let's say we started here, we went down, and then there, 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 and I messed up. So let's go ahead and I'll just clear and let's start over. So let's say we started, oh no. Oh well. So let's say we started here instead, I apologize. So this would be section 1, this would be section 2, this would be section 3, this would be section 4, section 5, 6, 7. Now remember, we don't mind if we go back to where we started, but then we have to be able to make it to that last spot, and that makes 8 traveled sections on that one. So that would be for the inspector trying to hit all of the locations. All right, so kind of cruising along. Next example. Remember, all we're really doing is trying to do tie-ins. Let's have a quick discussion. So in this case here, we notice that this particular, I'm going to go ahead and clear real quick. This town right here would have what we call a degree of 3, because it has 3 different ways. This one has a degree of 3, a degree of 2, a degree of 4, because there's 4 different ways. That would be a 2, and that would be a 2. And so kind of think about that degree and about where we start, where we end, and whether or not we can accommodate certain situations is kind of what we want to be thinking about here. All right, so now the next situation is looking at each of these and keeping in mind that we're trying to figure out whether or not the highway inspector and the traveling salesman can do what they want to do. And so as a quick reminder, remember that the highway inspector wants to travel to each section and not travel on one road more than once. So let's take a look at that one for just a second. So we take a look here. Let's say that the highway inspector started at this guy right here. Okay, so that would be up one, then down one, and then at that point, there's no economical way for the highway inspector because they would have to travel on this road a second time to be able to go back up to X and go down. So let's think about that another way. So let's say the highway inspector started here and went down. Well, once again, that wouldn't work because they had to travel back and then down and then back and then down and then back. So that breaks their requirement. So the highway inspector does not work for the first one. So let's take a look at the highway inspector for the second one. So remember, we want to go to each section and not travel on a section more than once. So we go down, up, down, and then we have a problem. Because if we wanted to hit this section, we'd have to travel on that twice. So the highway inspector does not work for either one of these. So let's take a minute. Let's erase this. Let's take a look at the travel and salesperson. And so the travel and salesperson, take a look at the first one. And remember, their goal is they want to go every town once, and they don't need to travel on each section. So if we wanted to go to every town once, all right, so now for the salesperson, let's say they started at X, they could definitely go down, hit that guy, and they don't care about traveling the same road, but they had to come back to X each time. So the whole thing here is they only want to go to each town one time, and they'd have to go to X several times. So the traveling salesperson would not work either for this one. So no highway inspector and no traveling salesperson for that one. Let's take a look at the next one. So traveling salesperson wants to go to every town once. So let's just say hypothetically we started here. That'd be 1 town, 2 towns, 3 towns. Oh, okay, well, maybe I can find a different way to do that. So that didn't work because I'd have to go back to this town a second time. So maybe I can start here and end here. Let's see if we can do that. So let's get the eraser. All right. And so here we go. So let's say we started here and we went 1, 2, 3, 4. There we go. So it looks like the travel and salesperson check that would work. And we've already established the highway inspector would not work for this one. So now if we look at our degrees here, the idea would be is that we started off with an odd degree. We had an odd degree, we had an even degree, we had an odd degree, and we had an odd degree. So kind of looking at those degrees and start making that connection with the theorems we're about to introduce is going to be valuable. All right, so talking about the degree of the town, we've gone through and we've looked at this and talked about it, So just as a quick refresher, A would be a third degree, C would be a second degree, 1, 2, 3, 4, 5. That would be a fifth degree, 1, 2, 3, 4. Fourth degree, 1, 2, 3, third degree, 1, 2, 3, third degree, and second degree. All right, so considering the map given below, let's focus on what happens at town A, junction for a section of 3 roads. So what's happening at A is this idea that I have 3 different ways that I can leave this. So I could leave and come out, and what that allows me to do is allows me to be able to have ways in and out. So I can kind of come into that town and leave again as needed. All right, so if we take a look at that, it's kind of the same example here. So if we go back one slide. Oh, slightly different, sorry about that. So in this particular town, this particular route here that we have, this path, what we have is we want to use Theorem 4. So let's go back to Theorem 4 real quick. So Theorem 4 says that if each of the towns of a connected row system has an even degree, oops, sorry about that, has an even degree, then the inspector has an economic tour. Further, the inspector can end the tour in the town where they start. So remember, the inspector is the person that's going to travel to each section, but does not travel on one road more than once. So let's take a look at this and see. All right, so jumping into this guy. So we're going to start at A. We're going to try to end at some other location. We have all even degree functions. So let's make sure. So we got 1, 2, 3, 4. So we have a fourth degree over here. We have a fourth degree here. We have a fourth degree in the middle. 2, 4, 4, 4, 4, and 2. So what I'm going to do is I'm going to ask you to hit pause and see if you can't come up with the path of how this inspector could travel on every section without duplicating a section. So that has to be the most efficient. So remember that I believe that they don't mind if they go to a town more than once. They just want to travel on every section. So go ahead and hit pause. All right, so if we look at this, the thing we want to think about here is kind of build this, just try to find the full path. Initially could be rather challenging. So one particular strategy that's suggested is that we would start and just look at like a trip number 1 and try to build our way up off of that trip. So like, let's say, for example, we started here and so we had A, and that's where we're going to, actually, let's put S for start. So we started here and we're doing trip 1. So we went on this path right here. So that'd be 1. And then we came 2, and then we did 3, and then 4, and then 5, and then 6. And so like what we would think about that is like that would help us be able to say, okay, well, we could get back now. All right. So now we need to kind of build off of that. Maybe think of it like as a side trip. And so let's say that our next side trip, or our next piece of this would be 6 or 7, excuse me. So I'm just going to call that 1. And then we could come out here and do 2, and then come down here and do 3, and then come down here and do 4, and then 5. And at this point, if I cut back, that would be my 6, and then I could go back to the start. But I still have this bottom piece to finish off. So let's go ahead and say, okay, well, one way we could go is we could go here. That would be 1, and then 2, and then 3. And now we have an escape route. We have a way out. So now we have, in this case, that'd be 4, and then 5. And so now if we follow those paths, 1, 2, 3, 4, 5, 6, and we could still have an escape route to get back to the beginning. And then we have 1, 2, 3, 4, 5, and then we have to be able to have escape route to get back if needed. And then we could go onto the green and end up hitting all of them and have that route to get back. So now we've met the need for the inspector to have an efficient route through here. Now, you obviously could break that down and look at it as just one big piece, but it's kind of like a big long puzzle. So breaking it down into small parts might help. All right, so let's see what else we have left